Every single week inside your own kitchen, you are doing something that feels responsible, something practical, something that saves money and reduces waste. And that exact habit, the one you repeat without a second thought, is quietly building the chemical conditions for one of the most lethal cancers in the human body. Not over decades of fast food, not from smoking, not from anything exotic or avoidable only by the privileged, from reheating leftovers, 4 specific foods, 4 specific chemical transformations, and a cancer with a 12% 5-year survival rate sitting at the end of that chain. If you have ever pressed reheat on a microwave and felt responsible for doing it, the next few minutes are going to permanently change the way you think about what is happening inside that food. Before the 4 foods, you need to understand the one thing that makes reheating fundamentally different from first-time cooking. Because the difference is not temperature, it is chemistry. When food is cooked for the first time, natural reactions occur between proteins, sugars, fats, and nitrogen-containing compounds. In most cases, the carcinogenic byproducts produced by those first-time reactions exist in concentrations the body can handle. The liver metabolizes them. Antioxidants buffer them. Immune function neutralizes them. The system holds. But when you reheat that same food, 3 things happen simultaneously, and none of them are safe. First, whatever antioxidants were present in the food during the first cooking have already been partially destroyed. The biological buffers are weakened. Second, the same chemical reactions that produce small concentrations of harmful compounds during first cooking are triggered again, but now without those buffers to manage the output. Third, during the hours or days between cooking and reheating, bacterial activity and enzymatic processes within the food have been converting certain compounds, particularly nitrates in vegetables, into more reactive intermediate forms. When heat is applied again, those intermediates are driven forward into a specific class of compounds that cancer researchers have been documenting for decades. N-nitroso compounds, commonly called nitrosamines, and a second class called heterocyclic amines. Both have been classified by the International Agency for Research on Cancer as probable human carcinogens. Animal research has provided strong evidence linking N-nitroso compounds to cancer development in multiple organs, and the pancreas is specifically named in that literature. This is documented biochemistry. It connects directly to the 4 foods below. The first food is processed meat. This is the one that almost everyone underestimates because they think they already understand the risk and they do not. Hot dogs, sausages, deli cuts, bacon, ham, canned meat, smoked meats, any meat that has been cured or preserved using nitrates and nitrites as part of its manufacturing process. These foods do not start from a clean chemical slate. They already contain meaningful concentrations of N-nitroso compounds produced during manufacturing before the food ever reaches your kitchen. The nitrites added as preservatives react with the amines naturally present in meat protein during the curing and processing stage. Nitrosamines are forming in the factory. You are buying a food that already contains documented carcinogens in its base state. When you reheat that food, you are applying heat to a chemical environment that is already primed. High heat accelerates nitrosamine formation. The higher the temperature and the longer the exposure, the more the reaction compounds. Microwaving processed meat on high, or frying it a second time, produces measurably higher concentrations of nitrosamines than were present in the food before reheating. Research examining the specific mechanism of dietary N-nitroso compounds and pancreatic cancer risk found that high dietary intake of these compounds was associated with elevated pancreatic cancer risk. Studies examining red and processed meat consumption have identified heterocyclic amines, polycyclic aromatic hydrocarbons, and N-nitroso compounds formed during high-temperature cooking as key mutagens in this pathway. The practical rule is simple and non-negotiable. Processed meats contain their own built-in carcinogenic precursors. Cooking them once is already a chemical event worth minimizing. Reheating them at high temperatures is adding accelerant to a reaction that should not be encouraged further. If you eat these foods, eat them once. Prepared fresh. Never microwaved on high. Never reheated in a pan at high temperature. Eat them immediately and do not store them for the next day's lunch. The second food surprises people more than any other. Spinach. And not just spinach. Every high nitrate leafy green. Celery, beetroot, kale, carrots. People reach for these vegetables specifically because decades of correct nutritional guidance has told them these foods are protective. And that guidance is accurate. Fresh spinach is genuinely rich in iron, folate, vitamins, and antioxidants. Fresh spinach does support cardiovascular health and provides real nutritional benefit. The problem is not spinach. The problem is what spinach becomes when it is cooked, stored, and then reheated. Spinach contains naturally occurring nitrates. In fresh spinach, these nitrates are completely benign and are even beneficial for blood pressure regulation and cardiovascular function. But when spinach is cooked and then allowed to cool and sit, even inside the refrigerator, two processes begin immediately. Bacterial activity within the cooked vegetable and enzymatic reactions within the cells start converting those benign nitrates into nitrites. This conversion does not stop because the food is cold. Cold slows it. It does not stop it. The longer the cooked spinach sits, the more nitrite it contains. When you apply heat a second time, two reactions are triggered simultaneously. The heat drives further nitrite formation from any remaining unconverted nitrates, and the heat drives a reaction between the nitrites already present and the amino acids in the spinach, producing nitrosamines. A study published in the journal Foods specifically warned against storing boiled spinach for more than 12 hours at room temperature because of this direct nitrate to nitrosamine conversion pathway. Celery in particular contains extremely high concentrations of naturally occurring nitrates and is frequently cooked into soups, stews, and casseroles that are then refrigerated and reheated multiple times throughout the week. Each reheating cycle drives the conversion further. The World Health Organization's International Agency for Research on Cancer has confirmed that nitrosamines in food are established carcinogens linked to gastrointestinal and pancreatic cancers. The same vegetables you are reheating because they are healthy are chemically converting into compounds that work directly against the protection they were supposed to provide. The solution is straightforward. Cook spinach and leafy greens fresh in the quantity you will eat immediately. If you have leftover cooked spinach, eat it cold in a salad the following day. Cold does not drive the nitrosamine forming reaction forward. Heat does. If the choice is between reheating it and eating it cold, always eat it cold. The third food is cooking oil. More precisely, any food that has been cooked or fried in oil that has already been heated once. Most people have a vague awareness that reusing frying oil is not ideal. What almost nobody understands is the specific chemistry of why and how that chemistry connects to documented cancer risk. When a cooking oil, particularly a polyunsaturated oil like sunflower, corn, soybean, or canola, is heated to cooking temperature, a process called lipid peroxidation begins. The double bonds in the polyunsaturated fatty acid chains react with oxygen and heat to produce a cascade of oxidized compounds. Aldehydes, specifically acrolein and 4-hydroxynonenal. Polycyclic aromatic hydrocarbons, acrylamide, particularly when starchy foods are present in the oil. These compounds are genotoxic. They cause direct measurable damage to DNA. When that oil is reheated for a second use, or when food that was already fried in that oil is reheated, the oxidation process continues from where it stopped. Each additional exposure to heat compounds the damage. The smoke point of the oil, the temperature at which visible breakdown occurs, lowers with each use. This means the oil reaches its toxic breakdown threshold faster and at lower temperatures with every subsequent heating cycle. The concentration of aldehydes and polycyclic aromatic hydrocarbons increases with each reheating event. The International Agency for Research on Cancer has classified several of the primary compounds produced by repeated oil heating, including acrylamide and polycyclic aromatic hydrocarbons, as probable human carcinogens. Research examining the formation of heterocyclic amines, PAHs, and acrylamide in cooked foods has identified temperature and cooking duration as the primary determinants of how much of these compounds are produced. Every time you reheat French fries, fried chicken, fried fish, or any food cooked in oil, you are applying additional heat to a food already saturated with oil that underwent at least one prior oxidation cycle. There is an additional specific risk to reheating fried foods in a microwave that most people are completely unaware of. When fried food is microwaved, surface temperature becomes deeply uneven. Certain areas of the food reach very high temperatures while other areas barely warm. The areas that reach the highest temperatures produce the greatest concentrations of heterocyclic amines, polycyclic aromatic hydrocarbons, and acrylamide. And this scorching often happens at a microscopic level that does not produce visible browning. You cannot see it happening. The practical rule here is equally clear. Never reheat fried foods. Eat fried food once, immediately after preparation. If reheating is unavoidable, use an oven at moderate temperature to warm the food evenly. Discard frying oil after one use without exception. The fourth food is rice. And this one operates through a completely different mechanism than the previous three, which is why it matters that you understand it separately. The risk from reheated rice is not primarily about direct chemical carcinogenesis in the same way as processed meats, leafy greens, and fried foods. The risk is a heat-resistant bacterial toxin, a toxin that survives reheating, a toxin that, over long-term repeated exposure, creates the exact type of chronic intestinal inflammation that cancer epidemiology has consistently connected to gastrointestinal cancer development. When cooked rice is left at room temperature, a bacterium called Bacillus cereus becomes the central problem. Its spores survive the original boiling process and remain dormant inside the cooked grain. As the rice cools and sits, those spores activate and the bacteria begin multiplying. Bacillus cereus produces two types of toxins. One causes vomiting and develops quickly. The second causes diarrhea and is produced specifically during the storage phase rather than during or after reheating. Here is the critical fact that the majority of people who cook rice regularly have never been told. When you reheat the rice, you kill the bacteria, but the toxins they produce during storage are heat-stable and heat-resistant. They survive full microwave reheating. They survive stovetop reheating at boiling temperature. The bacteria are destroyed by the heat. The toxins remain in the food and are consumed with every bite. In the short term, these toxins cause nausea, vomiting, abdominal cramping, and diarrhea, genuinely unpleasant but recoverable. In the long term, repeated low-level exposure to these heat-resistant bacterial toxins contributes to chronic intestinal inflammation. And the connection between chronic intestinal inflammation and gastrointestinal cancers is one of the most extensively replicated findings across decades of cancer epidemiology research. Every time the intestinal lining is irritated by heat-resistant bacterial toxins, the inflammatory response leaves microscopic cellular damage. Across years and decades of weekly exposure, that accumulated damage creates the precise cellular environment in which cancer development becomes significantly more likely. The protocol for safe rice handling is specific and must be followed consistently. After cooking, cool rice rapidly, within 1 hour, and move it directly into the refrigerator. Rapid cooling prevents the temperature from remaining in the bacterial growth range long enough for significant toxin production to occur. Store refrigerated cooked rice for no longer than 24 hours. When reheating, reheat once only and ensure it reaches steaming hot temperature throughout the entire portion, not just warm in the center. Never reheat rice a second time under any circumstances. The most effective change is simply cooking rice in smaller quantities so that less is left over. If cooking in large batches to save time during the week is a current habit, that calculation needs to be reconsidered. The time saved is not worth the cumulative risk of weekly bacterial toxin exposure compounding across years. Here is what these 4 foods have in common when you step back and look at the full picture. Each one represents a case where a cooking habit that feels sensible, practical, or even health conscious is producing chemical and biological consequences that work in direct opposition to your body's long-term health. Reheated processed meats deliver nitrosamines directly linked in research to pancreatic cancer risk, classified by the IARC as probable human carcinogens, with concentration increasing with each reheating event. Reheated spinach and high-nitrate leafy greens convert their naturally beneficial nitrates into nitrites and then into nitrosamines through a heat-driven reaction that is entirely preventable by one simple behavioral change. Reheated fried foods and cooking oils produce an accumulating genotoxic load of aldehydes, polycyclic aromatic hydrocarbons, and acrylamide that directly damages DNA, with every additional heating cycle compounding the damage from all previous ones. And improperly stored and reheated rice delivers heat-stable bacterial toxins that survive the microwave and accumulate their damage as chronic intestinal inflammation across years of repeated weekly exposure. 4 changes. Applied consistently. Never reheat processed meats at high temperature. Eat cooked spinach and leafy greens cold the following day rather than applying heat a second time. Discard used cooking oil after one use and do not reheat fried foods. Cool rice within 1 hour, refrigerate immediately. Store for no more than 24 hours. Reheat once only to full steaming temperature throughout. These 4 changes applied to your weekly kitchen habits meaningfully reduce your direct exposure to the specific classes of compounds that researchers and oncologists have connected to the cancers with the lowest survival rates in modern medicine. Your kitchen is not supposed to be working against you. Now it does not have to be.